from the perspective of a research biologist, which is what I am. For the past 13 years, I have been bringing, oops, you need a slide, don't you? I have been bringing other scientists and their graduate students here to these two islands to explore, to discover, describe, and tell you about the unique plants and animals that live here. And believe me, it's quite amazing from a global perspective, although very few people know about it. Oops, that's not what I want. We need to do a little homework first. These two little islands are called Oceanic Islands. They're true Oceanic Islands. Unlike the first one in the chain, Bioko, these islands arose de novo from the bottom of the ocean, up through 3,000 to 4,000 meters of water. And as such, they have never ever been connected to the mainland. Now this means that all of the plants and animals that currently live here, occur naturally here, had to cross from Africa a saltwater barrier in order to get here. There was never a bridge. Now we call this dispersal. And dispersal comes in many forms. You can imagine that a flower seed or small insects or spiders or what have you can easily be blown off the mainland and land on Sao Tome or Principe. Larger forms of life can float over. I mean, we know coconuts float. They're very, I'm having trouble with keeping this thing on my head, sorry. This is what we call rafting. But one way or another, once these organisms come across, they become isolated from their parent populations on the mainland. And if they are successful colonizers and begin to breed and their populations grow, they begin to accumulate change. This is what evolution is all about. The accumulation of genetic change over time. And if the time is great enough, and if there is a larger amount enough of it, ultimately these become different species, no longer closely related to the original populations on the mainland. We call these endemics. Endemic species is a species that's found only one place and nowhere else. Time is a very important factor here. Much of what we know about island biogeography, and it is indeed a separate, wonderful discipline within biology, comes from the study of the Galapagos Islands. You all know about Charles Darwin, the finches, giant tortoises, and the Hawaiian Islands, where many, many, many studies have been made. I should tell you right now that the oldest Hawaiian island and the oldest Galapagos Island are only 5 million years old. That's a geological snap of a finger in time. That's nothing. Let's look at Sao Tome, the very island we're standing on right now. The oldest rocks, exposed rocks on this, the bigger island, are 13 to 15 million years old. That's 3 times older than Hawaii and the Galapagos. And when we go across the ocean to the next island, Principe, it is 31 million years old. That is deep, deep time. That is time for lots of change. And it's not hard to imagine that there have been a series of successful colonizations from the mainland, development, accrual of change, evolution, and extinction. The natural occurring endemic species that we live with today are the result of the most recent ancestors of the most recent colonizations. Well, a biogeographer looks at an oceanic island that has been isolated for many years and predicts that there will be a fairly high percentage of unique species for the reasons I just told you. And believe me, Sao Tome and Principe have this in spades. These are just the larger critters. There are many more. I don't know how many of you know this, but fully 60% or more of the land snails found on both islands are found nowhere else in the world. One island or the other. The plants, our plant groups are fairly numerous. They're about 10 to 20% endemic, meaning 1 or 2 out of every 10 flower you look at or plant is found on one island or the other, sometimes both. However, within the plant groups, some of the families like begonias are fully half unique to these two islands. It's incredible. Reptiles, this is my field, and we're working on this now. About 75% of them are unique here. Of tremendous interest to tourists and to bird fanatics, and believe me, the world is full of them, are the birds. You saw in an earlier presentation there are 24 or 5 species, not so. There are 28 unique species, even 4 unique genera, that's a larger group, of birds on Sao Tome and Principe. If you put Sao Tome and Principe together as they are today, you have 1,000 square kilometers. It's tiny. And yet, because of that, it has the highest concentration of unique birds in the world by unit area. And just as by comparison, the Galapagos Islands are 8,000 square kilometers put together. They have 22. And moreover, they're all related to each other. They're all finches or mockingbirds. Here we have stuff from across the map suggesting many, many dispersal events. To me, one of the most fascinating groups that doesn't even belong here are the amphibians. Amphibians make lousy dispersers, which we'll get to in a moment. But it's the last group of animals that that a scientist would predict would be on an isolated oceanic island, including, by the way, that's called the cobra bobo, for those of you who live here. It is not a snake. It is a legless amphibian called a Sicilian, and it's known from nowhere else in the world but this particular island. Not only do we have it, but I just learned yesterday we have 8 species, not 7, believe me, not that. We have 8 species of amphibians on these 2 islands that are found nowhere else in the world. Again, this is just the tip of the iceberg, because my people study mosses, insects. We've had 2 marine expeditions. We have new barnacles. Every time we come, we find new, interesting stuff, adding to the biodiversity of these 2 little islands. Even though there are endemics to both islands, and the islands are, one island is twice as old as the other, some are still each other's closest relatives. This beautiful little impatiens is found on top of Pico Mesa and Principe. Unique to that area, its closest genetic relative is found higher up on this mountain above 1,000 meters, also an impatiens. 2 different species, yet they're related, and we call them sister species. This gecko, we just described it last year, the Principe golden-eyed gecko. Its closest relative is Greece's giant gecko, which is right here, endemic to Sao Tome. Well, not only do we have a large accumulation of unique species, but we also have species that represent really weird island phenomena, which we've known about for some time. Think of the giant tortoises of Aldabra, or the giant tortoises of Galapagos. For some reason, some groups of animals grow bigger on islands, and by the same token, some become much smaller. Call this gigantism or dwarfism, and dwarfism. Many of you are familiar with this, this wonderful begonia. It is the world's largest begonia. Most begonias are about that high. This thing is 5 meters high and only exists above 1,000 meters on Sao Tome. 2 years ago, on Principe, we found what we think is the smallest population of begonias in the world. A different species. It is fully mature and producing seeds at less than 2 centimeters. So you have both ends of the spectrums on these 2 islands. Sao Tome has the world's largest sunbird, the world's largest weaver bird. Little Principe has Africa's largest tree frog, which is, frogs are cool. And then, of course, I think you all know about the dwarf olive ibis, the world's smallest ibis, and probably the most threatened endemic today on these islands. Okay, as I told you, we've had 7 terrestrial expeditions and we've had 2 marine ones, and virtually every time we come back, we have new species. Species that have no names, that have never been discovered by the world of science. And to give you an idea of the rate at which we're finding stuff, mushrooms is a classic example. In the early days, the first major botanical work listed 18 species of mushrooms. We now have 225. Fully 30% of them have no names. They've never been described. Not only do we have amazing endemics, but we have animals that shouldn't be here. And I already implied that this is the case with the frogs. You put a frog in salt water and it dies. It has to do with its physiology. And yet, we have now 8 species of 5 different families, including our cobra bobo. How do animals like this cross several hundred miles of salt water? Well, our hypothesis is by rafting, by floating across, but not on small logs, not on small floatable things, but rather big chunks of riverbank. I want you to consider that 2 of the world's mightiest rivers enter into the Gulf, the Bight of Guinea, or into the Gulf of Guinea, the Niger and the Congo, with its enormous watershed. During rainy seasons, you already know that vast amounts of fresh water that pour down these rivers and into the ocean. What would happen if a large chunk of riverbank the size of this room, or 8 times the size of this room, broke off and floated down the Congo to the ocean, or the Niger, which of course used to be up there, down to the ocean? Well, the first thing that would happen is they would encounter some very old currents. We have no reason to believe that these currents haven't been the same since the Atlantic opened up during the Cretaceous. Well, one coming down the Congo would encounter the south to north Benguela current, or one floating down the Niger, the west to east Guinea current. These 2 currents converge, change direction, and become the south equatorial current that goes directly through Sao Tome and Principe, or the Gulf of Guinea Islands, that has for millions of years. There's another thing that strengthens our hypothesis that it was large rafts, many more than one, because these are all endemics of the 2 islands that I've mentioned, that many of them are burrowing animals. They're found under things or under the ground. This is not the kind of an animal that's going to be floating along on top of a palm tree across the ocean. Okay, what can we learn about these that has to do with broad-based biology, not just local endemism and difference and age? Let's look at the distribution of some of these animals. This is the cobra bobo, which is broadly feared here, by the way, and is absolutely harmless. Couldn't hurt you if you ate 10 of them. It's only found on Sao Tome, and again, it is an amphibian. Its only other relative, only other member of this genus, is found thousands of kilometers away in East Africa in several old river deltas, Tana River and another. Nothing in between. What accounts for that? We have a bat here on Sao Tome called Newton's bat. Its nearest relative is an undescribed species in Zambia. This is fairly new research, by the way. And together, these 2 are related to something up in Ethiopia. I'm dying here, aren't I? That is what we call a disjunct distribution. How is it that these related animals are so far apart? Finally, a tree that you may well be aware of called Afrocarpus mani. It's a yellow wood. It is only found on Sao Tome above about 1,000 meters. Its nearest relative is widely distributed on old mountains in East Africa, thousands of kilometers away. Well, clearly at one point, their mutual ancestor had to be in between somehow. How do we explain this? Well, this is the way we do. Here is a sort of a construct of Africa looking obliquely from South Africa. And you'll notice that there are some exaggerated but true mountain ranges and features that would serve as east-west barriers for movement of animals. We start, of course, with the Great Rift Valley, which starts down here in Zambia, goes all the way through, is visible from space up to the Gulf of Aden. You have the Mount Kenya Massif, Ethiopian Massif, the elevated Lake Victoria Plateau, the Albertine Rift, the Ruwenzori, and the depressed Congo Basin. These are all barriers to animal and plant movement. But it's important to know that virtually all of these geological features are fairly recent. In fact, in geologic times. In fact, East African rifting only started 11 million years ago. But our little islands were already here and had been here for some time, right? So we think, and this is not just my idea, it's been brought up before, that 30 million years ago, Africa was fairly flat. And that there was a continuous tropical fauna, plants and animals, that extended all the way across. And that millions of years of climatic change and geological change disrupted all of the intermediate ancestors of this particular unique fauna, leaving behind the descendants of this millions of years of evolution on our two little islands and on some of the older islands in East Africa. At least that's the hypothesis we're working on. No one has shut us down yet, but we'll see. All right, as Mark already said, and as you all know, these are exciting times, and they're times of great change. The title of this talk is Island Biodiversity Race, which is also the title of a blog I've been writing since 2008 about our work here. With coming development comes change in habitat. We've heard about oil, of course, all of us, deep water ports, new business hotels, and an expansion of industrial scale agribusiness, monoculture. Well, all of these sorts of things have negative effects on the environment. Most of them do. So part of the race first is to find out what's here before it disappears. And I've already told you the rate of the new stuff we're finding is phenomenal. But second, it's also important to let the citizens of Sao Tome and Principe know how unique and special you are biologically. To this end, we've been writing papers and publishing books now for years. I've been working in Africa for 30 years before I came here. And this informs the scientific world. Other scientists read our stuff, and we send our publications to their appropriate ministries, etc. But what about the people who live here? They don't get the information. So we decided a few years ago that we would start also an educational campaign. Now the research keeps going. It's always ongoing. But the first thing we did back in 2011 was we put together 200 plasticized posters which in fact highlight endemic species of Sao Tome, of Principe, and then 3 that mix them together. And these are, we put them on every vertical wall we could find on both islands. I'm delighted to say they're still here. But then we thought, no, let's go after the kids. You all know about McDonald's, right? McDonald's is the most, famous, most successful food chain in the world. Well, Roy Kroc, who started McDonald's, did not call adults' attention to McDonald's. He marketed to kids. And the kids took their parents to McDonald's. So we decided we'd go after the 3rd grade. And so the next year we produced 2,000 coloring books. Each page a cartoon of a unique animal and plant from Sao Tome or Principe. And we literally gave out 2,000 of them to selected schools on both islands. And they were well received, believe me. This last year, by the way, I just got back. There were 9 of us here all of April. We decided on playing cards. And these cards, in fact, all the black suit are Sao Tome endemics, all the red suit are Principe endemics. We showed the teachers of all these schools how you could use them as matching games. Oops, I'm sorry. At any rate, we fully expected it to go up the generational ladder. This was taken a few years ago. Those are adults playing cards down in Santa Catarina. We're going to continue with our educational projects and our research, and thank you for your attention.